Okay, business algebra, sorry. I was gonna do this morning, but then life got in the way. Okay, so we did graphing individual lines and determining which side to fill in for the inequalities in two variables. When you have two different lines, you're going to graph them both individually, but then that's gonna split it into four areas usually. You'll need to find which of the areas satisfies the equation. Now technically you can still plug in one point and use what you learned from that one point, and we'll see how this works. Okay, so the first question is, y is less than 1/2 x plus 1. As a reminder, it's less than, so I'm just going to deal with this one first. So it's a dotted line. So we start at 1 and a slope of 1/2, so up 1 over 2, or down 1 and to the left 2, up and right or down and left. And we just keep going forever and ever. Remember, this is a dotted line, so once you have enough points that you're confident you can make your dotted line, you can do it. Okay, so now let's graph the other line, and then we'll worry about which side of the line we're shading. Y is greater than or equal to 3x minus 1, so we start at -1. A rise over run of 3, up 3 over 1, or down 3 to the left 1. This is an equal to, so it is a whole line. Okay, so now notice there are now 4 sections. You can still use your above and below that you used before. We still expect it to be below the blue line, but above the pinkish red line. So where's below the blue line? It's these two areas. And which one's above the red line? It should be these two. So the areas they overlap is here. You can check 0, 0 if you want. Is 0 less than 1? Yes. Is 0 greater than or equal to -1? Yes. So that means we will shade this area. Now, how would you do this the algebraic way? Some people say you have to plug in a point from each area. That's not entirely true. Let's see what happens if we plug in 0, 0. We get y is less than, or 0 is less than 1. And here we get 0 is greater than or equal to -1. They both work. If you get they both work, then that's automatically the area you shade. If they both didn't work, you go the opposite. And depending on which one, if only one of them works, it depends which one works. It's the other two. Now we'll do it that way on the next problem to see what I'm talking about. Okay, so y is less than -3/5 x plus 1. Start at 1. -3/5 means down 3 to the right 5, or up 3 to the left 5. It is a dotted line. Okay, so 2x plus 3y is less than 6. I need to solve for y. So subtract 2x. 3y is less than -2x plus 6. So y is less than -2/3 x plus 2. So we start at 2. Slope of -2/3, down 2 over 3, down 2 over 3. So this one's a little trickier. Down 2 over 3. Okay, so we'll talk about this. -2/3, it's a slightly stronger slope. So this is an awkward equation because these slopes are so close together. It should be dotted. Imagine this is a dotted line. Eventually down here, they're gonna cross. So we'll draw the picture going out. Now, either way, they're both less than, so we expect it to be under both of these lines. So again, 0, 0, looks like it's in the region. If I ask myself, plugging in 0, is 0 less than negative 3/5 times 0 plus 1? Yes, because that's just 0 is less than 1. Is 2 times 0 plus 3 times 0 less than 6? Yes, so that means 0, 0 is in the region. And we shade the area where 0, 0 is, which is under these lines. Now, page 4 has more than 2, but the principle is still the same. You do the exact same thing, you just have more stuff to deal with. Okay, so y is less than or equal to 2x plus 8. 1, 2, 3, 4, 5, 6, 7, 8 is up here. It's a down 2 over 1. I don't have any room to go up, so we're going to go the other way. It's a solid line. Y is less than or equal to x plus 6. So we start at 6. Up 1 over 1 or down 1 over 1. Losing count, no. 1, 2. Okay, here, here. Okay. Awkward, but it's fine. So these are those two lines. Now, one thing you notice, it's got to be under those two, but I'm not done yet. I still have this x is greater than or equal to 0 and y is greater than or equal to 0 lines. Now those are actually both the axes. So when it says x and y are both positive, which is what this really means, it means I have to be in the first quadrant. So which areas are under both of these lines, but also in the first quadrant? So if I just restrict myself to here, but under for both lines, it's clear that this is in the region. Now, you technically can't test 0, 0, it's on a line. So if you can't test 0, 0, pick something else easy, like 1, 1. 1, 1 is in the area, so it should work for everything. Is 1 less than 2 plus 8? Yes. Is 1 less than 1 plus 6? Yes. Is 1 bigger than 0 and 1 bigger than 0? Yes. So that one does work. And lastly, when you have these double inequalities, it's really like there's two. It's like x is greater than or equal to negative 2 and x is less than or equal to 2. Those are both vertical lines. I will draw. So it kind of makes a double line on both sides if it's the same number. Same thing for y with negative and positive 4. They'll make double horizontal lines. The other ones are vertical. These are horizontal. So when I have to be between these lines, that restricts me to just this little rectangle in the middle. The last one is y is less than 2x plus 1. I'm going to use the black pen and make it's a dotted line. So start at 1, up 2 over 1, or down 2, down 1. Should be dotted. Okay, so I'm in the box, and I need to be under the dotted line, which would restrict me to, I think, this area. So again, 0, 0 works. I promise 0, 0 doesn't work all the time. It just so happens to be working in these cases. So if there's more than one, you just repeat the process over and over. And that is it for this section.